Hello everyone. Today we'll be solving the problem minimum size subarray sum. Now what the problem suggests? Given an array of positive integers numbers, that means we are given an array and a positive integer target. So we are given a target. Return the minimum length of the subarray whose sum is greater than or equal to the target. If there is no such subarray, then return 0 instead. Okay. Now let us understand the problem. Okay, we are given this array. The array is 2, 3, 1, 2, 4 and 3. Sorry about the handwriting. Okay, now our target is 7. So we need to find the maximum sum and equals to maximum sum of 7. That is, the minimum should be 7. It can be also 8, so they don't have any problem. And if we don't find, we need to return 0. So how the 2 is coming as the output? So the explanation suggests that the subarray 4 3 is minimum length of the problem constant. So they have written the length of these two, which gives us a 7. Now how to solve the problem? Okay, now to solve the problem we need few constants. That is, we'll be solving using a sliding window protocol. Now what is that? Okay, let us understand by this solving this example. We need first L right, these two pointers. We need sum, we need length, and we need the answer, that is mean length. Okay, okay, so we'll put two pointers. Okay, this pointer and this pointer. Okay, this is first is L and this is right. Okay, first is 0 and R is 1. Will be the sum, that is 5. So the length is, so as it is sum is less than, sum should be greater than equals to 7, right? So as it is 5, we'll just move the right pointer. Okay, so 0, 2. Now what is the sum now? 6. Okay, so what we'll do, we'll again move the right pointer, that is to 3. So it has come to here, so it becomes 8. Now what's the length to calculate, because it is greater than 7? So the length is 3, right? That is R minus L, so and plus 1 also to get the exact answer. So we'll write this as a 4. Okay, so the minimum length changes to 4. As the length is 4 and the sum is greater than equals to the target, what we'll do, we'll now move the left pointer to here. Okay, now L is here, so we'll move our left pointer as here, so 1 and 3, right? Now what will be our sum? So the window is currently pointing here. This is the window we are calculating. So 3 plus 1 is 4 and 2 6. So as it is less, so we'll move the right pointer, right? So it became up to here, the window became here. So 1, 2, 4. So now as it was 6 plus 4, that is 10, right? Yeah, now it is 10. So as it is greater, now we'll be calculating, that is 1, 2, 3, 4. So again the length is 4, minimum length will remain constant. Now as it is greater, we'll be moving our left, so L will be pointing here now, and our window will become this. So it will be pointing 2 to 4. It will be pointing 2 to 4, that is 6 plus 7. So answer is 7. Now the length will become 3, will update as a minimum 3. Now again we'll move the left to here, so the window becomes 2, so it becomes 3 and 4. Now it will become 6. As it is less, we'll move the right pointer to here, so 3 will become 5, and we'll get as a 6 plus 3, that is 9, and the length will be 3 again, so no change here. Now for the next pointer, what we'll do, we'll just move our left pointer to here, and our right pointer is already here, so 4, 5, 7, our sum will become 3 plus 4, 7, and length will be 2, and we'll be updating our minimum length as 2, right? So this is the algorithm goes. Now what is a sliding window protocol? If you consider, first we took this size, then this, and then we are taking this size, and again at the last we took this to find out our answer. So this is actually the sliding window protocol. Now we'll be writing the code here, right? Now what we need, we first need 2 pointers, so it will point here, it will point 1, as we have seen here. First 2 will be here, left and right? So we are done with that. Now we'll put sum as we are calculating. Now the sum will contain the first element, that is nums of 0. Okay, min. Now we'll put, to calculate the mean length, we'll first take the maximum value. So we have got the constants. Now what we'll do, now we need to iterate. Okay, so I will do that. We'll put a while. Now in while, what will be the conditions? We'll first check that the L should be less than R, and then R should not go beyond the length. Now let us take also the length too. Now what we'll check, first what we'll calculate the sum. Sum is equals to sum plus nums of what? Nums of R. Okay. After doing that, we'll first the length, that is, we'll first now calculate the sum we have calculated. Now we'll check that this is less than 7 or greater than 7. If it is greater, we need to increase this length, right? So let's do that. So what will be the condition? First condition will be sum. If sum is greater than equals to target, then what we'll do? First, if the we'll first calculate the length. L is equals to, what will be the length? The length will be r minus L plus 1. Okay. Now we'll be putting that, calculating the mean length. Math.min. So math.min will contain the mean length, right? Mean length comma L. Okay, we're done with that. We'll be calculating that. Now if we, what we said in the algorithm, that if we find it is a greater, as we did here, 10, then what we did, we just decremented this, and we also decremented the sum also, right? And we checked again, and if it is greater, we will be reducing this. So to do that, we will first, what we do, we will do first subtract. Sum is equals to sum minus nums of L, right? After that, we'll do a L plus plus, that goes. Now to keep R in the boundary, so if R is less than N, we'll do R plus plus, nothing more than that. We did it here. As we check the condition, R should be less than N, then only we will increment, because as you can see, it has already reached to the N. N is 6 here, so 5 is less than 6, right? If it goes 6 is equals to 6, then there is a no point, it will be runtime error. So for that, we'll be checking this, right? Now we have completed the code. Now there are few conditions. If there is no such array, we will return 0 instead, but here we took a max dot value. Now for that, what we'll do, we'll put a check condition. If mean length is equals to integer dot max value, then we'll return as 0, otherwise we'll be returning, what will be returning, we'll be returning the mean length. Done, we are done with the code, but now we need to find another edge conditions. Now what will be the edge condition? Now suppose our first letter is, now suppose our target is 2 and we need to find the minimum length. Okay, it will be the first letter, but as we are calculating here sum plus sum here, so I think for that we need to put a check. Now if nums 0 is greater than equals to target, then return 1. Okay, I think we are done with the code. Now let us check. Already defined the method. Okay, len okay, we are ready to go. Alright, we got accepted. Now this is how the algorithm works. So let us first understand. So this is the algorithm we used, same in the code. We first calculated the sum. Now if the sum is greater than target, we will be reducing the sum from length and will be calculating the length, and it will be keeping the right boundary, right pointer within the boundary, and we'll be checking. These are the few conditions we need to keep in mind. So thank you everyone. See you in the next video.